Hi Pre-Calc students, Mrs. Fellon here. We are on so this is the video for section 1.5 in unit 2. And what we're looking at is we're going to need a graphing calculator for this unit. So if you have your graphing calculator, grab it because we need it. All right, I'm going to walk you through the first couple examples on page 8 of our notes packet that you guys should have. And I'm going to walk you through the couple of these, how to find it. So first, what you notice is that we have this really kind of crazy equation. We're going to go ahead and throw that into your y equals. So hit y equals, and then let's type all of this in here. So 2 square root of x minus 1, and then just hit the cursor over here to kind of end that, plus 3, and then square root of 6 minus x, and then again hit the cursor over here to kind of end that square root, and then minus 6.5. So we've got a lot of weird stuff going on in our graph. I'm going to hit zoom 6, and what zoom 6 does is it brings me to a standard window, which actually doesn't look too bad for my graph. I can see my whole graph. What I'm going to do is I'm going to change my window so I can kind of see it a little clearer. So if you notice, there's a lot of empty space here that I don't need. So I'm going to hit the window button, and I'm going to change my x minimum to 0 because there was nothing on that side of the graph. And my x max I'm going to change to 8. X scale just means what do you want to count by. So I'm going to count by ones. My y min, I'm going to go down to -8 and my y max to be 5. And again, I want my scale to be 1. All right, so that's just a little bit better, I think, of a graph, a little bit better picture. So what I'd like you to start is I'd like you to sketch a graph of this. So kind of on your paper, you're just going to sketch this graph, and then we're going to kind of label all of the important parts, okay? So I'm going to kind of, it's about right here, and then it goes here. So the important parts that we want to label are going to be these endpoints here, this max, and this 0. So we're going to go through all of those steps. Let's first do the two endpoints. So the two endpoints, we need to use the trace feature. So just hit trace. And using only your left and right arrow keys, let's go ahead and find the ends of that graph. So let's just kind of move our cursor all the way to the very end. And see how my y value doesn't have anything there? That's because I'm off my graph. So go back. So that looks like I have a point there. So this point looks like it's 1. We'll just round that to 1. Well, I guess we'll call it 1.03 and then 0.54 if we round it. So that's what that point is right there. Let's use the trace. We're just going to move my cursor all the way to the other side now. See what that end point is. Oops, went too far. Okay, so now this is 6 and 2.02 or 2.03 around it. All right, let's find our maximum. So if you remember from our previous video with Mr. Klein, you hit second trace, and you're going to find your maximum. So this is the highest point, so we're going to call it a max. Hit enter. It asks you to go left bound and right bound. So again, just using your left and right arrow keys, move your cursor to the left of your max, somewhere to the left, doesn't really matter where. Hit enter. Move your cursor somewhere to the right of your max, hit enter, and then hit enter again. All right, we get a max of 2.54, comma 1.56. All right, the last piece of information we need is this 0 or x-intercept. So hit second trace again, go down to 0 this time. Remember, 0 is just another word for x-intercept. And basically the same operation, like the same kind of concept. We're going to move the cursor somewhere to the left of the 0, hit enter. Move the cursor somewhere to the right of the 0, hit enter, and hit enter again. And so I get this point to be 5.41, comma 0. All right, now that we have all this information, we should be able to answer the questions about this function. So the domain is your lowest x value to your highest x value. So if my lowest x value is here, it's 1.03. My highest x value looks like it's 6. And since we want to include both of those, we're going to use brackets around them. Likewise, for the range, we want our lowest y value, which happens to be oops, this was supposed to be negative 2.03. And our highest y value, which is up here at that max, is 1.56. And again, because we want both of them, we're going to go ahead and use the brackets. Our 0 is when x is equal to 5.41, because that's our x-intercept. Okay, increasing interval. This is the part of the graph that's increasing, right? If you read it like a book from left to right, you hit the graph, it's going to increase all the way up here to the max, and then it's going to start decreasing. So remember when you're doing the increasing and decreasing, you're only looking at the x's. So my x values are going to range from 1.03 all the way up to 2.54. And to be honest with you, from here on out, let's just use parentheses anytime we're using increasing or decreasing intervals. There was some talk about whether or not we can use a bracket or a parenthesis, and I think I originally showed you the bracket, which is fine. It's not incorrect. It's just, it doesn't really matter. So let's just use parentheses so we don't have to worry about which is which. So anytime you're using increasing, decreasing, we're just going to use parentheses. All right, for the decreasing interval, same deal. We're going to start from here. Our x value is 2.54, and it's going to decrease all the way to here where it's 6. So 2.54 to 6. And so that's really what I'm asking you to do. All right, let's go through another example. This one has an absolute value and a cube root, and it has a restriction. So grab your calculator. Let's go to your y equals. Whoops. Let's go to your y equals. Let's clear all this out of here. And let's type in this new function. So to get to absolute value, we have to hit math, and then go over to num, or number, and ABS is your absolute value, so hit enter. And I'm going to type in 4x minus 3, and I'm going to arrow out of that absolute value sign. Minus. To get the cube root, you want to hit math again. Notice that option 4 is cube root, and we want the cube root of x. And then arrow out of that, so we're just going to hit the right cursor. We moved on this restricted domain, and I know Mr. Klein walked you guys through this, so we're going to hit the division bar, and then we're going to have a parenthesis, and we're going to say x greater than or equal to. So remember on your calculator, to get greater than or equal to, you hit second math, and it's option 4, and we're going to do 0, and then close your parenthesis. All right, let's take a look at this graph. All right, so that's the window I used for my other function, and it looks like it's pretty good. Let's hit zoom 6, which is our standard window. Try that again, zoom 6. So standard window means we go from negative 10 to 10 on the x-axis and negative 10 on the y-axis. So you can kind of see a better idea or picture. Again, I'm going to adjust my window. We don't need all this space down here and over here. So on my x min, I'm going to make it, I don't know, -1. My y min, I'm going to make it -1. My x actually really didn't need to be that high either. So let's get a better picture of this. And maybe I want to go a little lower because I can't really see the bottom of that. So I'm going to go down from my y minimum, go back to window. My y minimum, I'm going to make that -4. And again, you can adjust this. There's not necessarily one correct window. It's just kind of your preference. All right, so we have this graph. Let's go ahead and sketch that graph like we did last time. So I'm going to go over here. We're going to find kind of the information that we're looking for here, right? So we're going to find the important information. So the graph kind of looks like an absolute value, or at least part of an absolute value. And it does this, right? It goes on forever, or at least it looks like it does. All right, let's find the important stuff. So I'm guessing the important stuff is kind of, you know, these points here. We may want to look up higher. I wonder if this goes on forever. Let's change our x max to, let's do something crazy. Let's go to 50. So see how it's going on forever and ever and ever? All right, so that's good to know. So I'm going to go back and change it since we don't really need to see all of that. I'll go back and change it to 8. But what we know with that then is that this is an arrow here, which means that's going on forever. So that's important to know. But we know that there's a point here, and then there's a couple zeros. So I think all of those pieces of information are important. So I'm going to hit the trace button. And I'm going to move my left arrow key all the way over. Now you can do the minimum on here too, like that. It's just not as accurate. So I would avoid doing trace for the minimum or the zeros. So it looks like this is the one that I need. This is 0.02, comma 2.6. Okay. All right, let's find that minimum. So this is a lowest point this time. So hit second trace, go down to option 3, which is minimum. You're going to do the left bound, right bound thing. So move your cursor somewhere to the left of your minimum, hit enter. Move your cursor somewhere to the right of your minimum, hit enter again. So I got 0.75, comma, negative 0.91. All right, we are going to ask for zeros, so let's do the zeros. So hit second trace. There's 2 zeros, so we'll just do one at a time. Hit the 0 feature. I'll just go to this one. Move your cursor somewhere to the left of it and hit enter. Move your cursor somewhere to the right or below the x-axis, hit enter. Hit enter again. So my 0 here is 0.55, comma 0. Let's go to do the same thing. So second trace, go down to 0, arrow over. So this time to the left of it would be below, hit enter. And to the right of it would be above, hit enter. Hit enter again. I got 1, comma 0. All right, so we got all of our stuff, which is important. So now let's find our information. All right, so our domain. Our domain is our lowest x value. So our lowest x value looks like it's 0.02. So 0.02. Our highest x value, because this is going on forever, it's going to be infinity. So we include this point. There was an open circle, or no open circle, it was a closed circle. So, and then we put brackets around here, parentheses around here. For the range, our lowest y value is negative 0.91. And our highest y value, again, because it goes on forever, is going to be infinity. Again, use the brackets around the negative 0.91. Our zeros are what we found here, which were 0.55 and 1. Our increasing intervals, well, if I read this from like a book from left to right, this is where it's decreasing. From here up is where it's increasing. Again, just look at your x's. So from 0.75, and it's going to be increasing forever, so we're going to go infinity. Use parentheses around both. Decreasing my x value, it's just from here to here, so 0.02 to 0.75. Again, use parentheses around both. All right, so when we're in class, you guys are going to try example on your own. You don't need to do it now. I just wanted to give you a couple examples of how to use your calculator to find all of that information. All right, let's do another one. We're going to go and do something a little bit more elaborate, which means we're going to turn the page and we're going to try a story problem. All right, so on this one it says, Chuck, a bird enthusiast who does research for a bird industry, models the population B of Blackhawks T days after the start of the year with this function. Use the table to complete this, or use this equation to complete the table. All right, so grab your calculators. I'm going to go second mode, which clears me out of here. And now I am going to go to my y equals. Let's try to get a good screen here. Go to my y equals, and I'm going to clear this out of here. I'm going to type all of that in. So be careful that you start off with the negative button. This is the negative button. Don't use the minus sign. So negative point, and it looks like there's 4 zeros. So 1, 2, 3, 4. 1, 5, and then x raised to the third power. And obviously we don't have a t here, so we're just using x's. Doesn't really matter which variable you put in your calculator, but you know. Plus 0.001 x squared plus 1.6x plus 124. Let's hit graph. All right, I don't see a picture. And so you can kind of tell from this that we're going to have kind of a big range. So it looks like my x's, at least on this table, go from 0 to 400. So go to your window. Let's change our x's to 0 to 400. And let's hit graph again. Nothing happens. All right, so let's go to our window. Oh, there's a little graph over here. I had to wait for it. All right, so let's go to our window. Let's change our Y min, like Y, I don't know, from 0 to 400. Let's see what happens there. All right, well, at least I'm getting some graph. It looks like there's a curve, and it's going down. So I might want to go a little further, because I want this curve. So I may want to go a little bit further on my X max. So maybe I go, I don't know, 450. I just want to see that whole thing. Okay. And I'm going to change my mind about the Y minimum and go like -50, because I want to see if it goes beyond the X axis. So I'm just trying to get a feel for what this graph looks like. We're really only care. Okay, so here's what I'm trying to get at. If we're talking about number of birds, then we don't care about like the negative, like we're not going to have a negative number of birds, right? Or a negative amount of time. So the only quadrant that works in this one is quadrant 1. So that's why I'm really kind of zooming in on quadrant 1. All right, so the next, what I'm going to do is I want to fill in the table. I'm going to show you a way to kind of fill in the table. So if you go to your second window, oops, go over here, second window, and it looks like our table is starting at 0, and we're increasing by 100. So see where it says that little triangle and PBL? I'm going to put in 100, and now to get to your table, hit second graph. So now enter in the values that we found. So when X is 0, Y is 124. When X is 100, Y is 279. When X is 200, we get 364. When X is 300, we get 289. When X is 400, we get -36. So pay attention to what this kind of represents, right? This is representing time, and this is representing number of Blackhawks or birds. So it doesn't make sense to have this one, right? Because we're not going to have a negative number of birds. So when we did our window, right, it made sense that we're starting at 124. We're going up to about 289 is kind of the max, and then somehow we're 364 is our max, and then we're going back down. So our window that we used is 0 to 450, and then Y minimum to Y max, I did -50, and you could put 0 here too. I just did -50 to kind of get a better picture to 400. All right, let's sketch the graph. So we go back to my graph. I'm going to go ahead and kind of really just kind of use the first quadrant. And then I'm going to sketch this graph. And we're going to find all of the important pieces of this graph. So we're going to find kind of the zeros and the the maximum on this. So we've done this before, so hit second trace. Let's go to find the max first. So go to the left, hit enter, go somewhere to the right, hit enter again. Looks like I got a max of 212. We'll just round to the nearest whole number, and 365. Let's find this 0, and then we probably should figure out what that number is, which I think we already know is 124, because we know that it starts there. Maybe we just go to trace and see what that is. Because when X is 0, Y is 124. So this should be 124 when X is 0. So I'm going to call this 0, 124. We knew that from our table. And let's go find this 0. So second trace, go to 0. Go all the way over, so you can go to the left of it. It'll be above your x-axis, so we got to go all the way over. Hit enter, go all the way below it, hit enter again. All right, so I get a 0 of 392, 0. All right, let's see if we can answer some of the questions that this is about. All right, find what the maximum Blackhawk population is and when it occurs. Well, Blackhawk population is referring to our Ys, because that's number of Blackhawks. And this is our time on this axis. So if I want the Blackhawk population, our max is at 365. So 365 Blackhawks. And then when it occurs refers to time, and that means basically day 212 of the year, whatever that will end up being. For Part E, it says the National Wildlife Service wants to contain the Blackhawk population to below 350. And so what we're doing here is we don't want to have too many birds. So during what time interval will we have to take action to reduce the population? So here's what we're going to do. We're graphing this function here. So we're saying y equals 350. So I'm going to graph the equation y equals 350 on my graph as well as on my calculator. So go to y equals, go down here and just type in 350 and hit graph. See how it's going to kind of hit my graph in two spots. What you want to figure out is where those two intersection points are, okay? So that I'm going to show you how to do that if you don't know how. So you're going to go to second trace. This time you're going to pick option 5, which is intersect. You're going to use your left arrow key, and it's going to take you along this blue parabola here. You're going to go somewhere to the left, and you're going to hit enter. And then you're going to jump up to the line, and you're going to go somewhere to the right and hit enter again. So what this is doing is it's finding this point here, and I figured out it's 168, 350. Let's do the exact same thing for the other side. So go to your trace, go to intersect. We're going to arrow over, hit enter. We're going to go kind of past it, hit enter again. So now I have 250, we'll round that to 253, 350. All right, so to answer this question, during what time interval will it take to reduce so basically what happens is when the number of birds gets higher than 350, we need to take some action. So at what time is the birds higher than 350? Well, from 168 all the way to 253. So I would say from 168 to 253 days. So we're talking about days into the year. Last thing says, assuming that this model needs to be accurate, when will the Blackhawk population become extinct? Well, when it becomes extinct, it means that there are no more Blackhawks. In other words, that it's 0. So we're going to go all the way down here to where it's 0. That's 392 days into the year. So that's actually more than 1 year, right? That's over a year. So it's after 392 days is when this Blackhawk population will go extinct. All right, one last thing that I would like to cover on the video, and that is the last thing I want to cover is this last page here. So you guys are going to do this in class, and then the last thing you're doing is this page here talking about even and odd functions. All right, so even function has reflection around the x, or has reflection about x equals 0. That means that there's a line of reflection right here. See how this half of the graph and this half of the graph match, right? If you fold it along that line, it would be equal. So odd functions have rotational symmetry, which means if we rotate this 180 degrees, and I turn this 180 degrees, this part of my graph will match up with that part of my graph. We call these even and odd functions. So ones that have symmetry about the y-axis or ones that have rotational symmetry. Algebraically, what you do to figure out if it's even or odd, you input a negative x, so you replace x with negative x. If it equals the original function, then it's even. In this one, if you replace x with negative x, and it equals -1 times the original function, then it's odd. That sounds really odd. That sounds really strange, right? So let me kind of walk you through a couple of these. All right, so on this one, prove whether or not these are even or odd. So all I want you to do is input negative x in place of x. So you're going to do Instead of x squared, you're going to say negative x squared plus 1 over negative x. Now simplify. Negative x squared is just x squared plus 1 over negative x. And remember, the negative on the bottom, just because it's on the bottom, all you're really doing is that means that you're multiplying the whole function by negative 1. So algebraically, we know that this has to be an odd function. Why? Because when I plugged in negative x, I got negative 1 times my original function. So we would classify this function as odd. Let's try another one. On the g of x, I'm going to plug in negative x. I get negative x to the 4th minus negative x to the 2nd plus 3. So I put that negative x in parentheses. It helps. A negative number to an even power is even, or positive, I should say, minus, so this is x squared, plus 3. So look at this function right here. It's the same exact one as what we had. So when I inputted negative x, I get my original function out. That's your even function. So this is even. Let me show you one that's neither even nor odd. So I'm going to input negative x again. So negative x to the 6th plus negative x to the 3rd. I'm going to simplify it. So a negative to an even power is positive, and a negative to an odd power is negative. So this is not the same, clearly. It's also not multiplied by negative 1. Otherwise, the x to the 6th would be multiplied by negative 1. So because it doesn't fall into either of those categories, we call this a neither. So this is how you prove it algebraically. To look at it graphically, what you would look for is whether or not there is symmetry here. So is there any symmetry along that line? Clearly, if I fold this, it's not going to match up. But now check rotational symmetry. If I rotated this graph 180 degrees, would this piece match up with this piece? And if the answer is yes, which it is, then this has to be an odd function because it has rotational symmetry of 180 degrees. All right, B. It doesn't have symmetry around x equals 0, right? So it's not even. If I rotated it 180 degrees, would the picture look exactly the same? Clearly not, because it would be like way over here, not over here. So this is what a neither graph would look like. Last but not least, again, check for even, which means it's a reflection across x equals 0. If I reflected this across x equals 0, I would have like a line, I would have a negative slope, right? So that's not going to work. Does this have, so it's not even, is this rotational symmetry? If I took this line and rotated 180 degrees, would I get the same picture? And the answer is yes. So it has rotational symmetry, so it's odd. We're going to work a lot more on this whole even odd thing, but I wanted to give you kind of just an introduction to it. All right, that's it for now. I'll talk to you guys later. Bye.